Welcome back to Neal on Fire, where we talk with the people building the future of wildfire detection, mitigation, and response. I'm your host, Neal Spungen. Let's get into it. Today, we're joined by Dr. Ryan Alimo, the founder of Opal AI, a company using spatial intelligence, multimodal data, and 3D modeling to assess wildfire and urban risk, map infrastructure, and help agencies make faster, smarter decisions before, during, and after disasters. Brian, it's great to have you.
Thank you, Neal, for inviting me. It's a great pleasure to be here and in this exciting moment about fire tech and how we're building technologies to help the community to make them safer. And thank you, listeners. If you're listening about this, hearing about this podcast, we're going to have lots of great technologies about AI and how AI is disrupting the fire tech.
So when we're talking about AI, everything is AI these days. People are confused. So for the listeners who may not know about your company yet, describe in simple terms what Opal AI does.
Yeah, lots of you heard about the ChatGPT and how you're going to use how it's being used. It was trained on the internet data, and there is a technical transformers that use it to predict the next word, and you get really good responses in the chat or in the data set that was trained on the images or the text. When it comes to the real world environment, these AI models are struggling. That's why in 2025, we see a new regime or new field that is called physical AI has been created. Opal AI is working the physical AI world, which means that we are building AI systems that are going to help the people, the community, the fire agency, utility companies to make decisions on real world environment with real world data. It can be a LiDAR data, it can be a sensor data, weather data, and then take actions accordingly.
Got it. So what specific problem does Opal solve that was not being solved well before the company existed?
So the first problem that we tackled was how we're going to create a digital twin of the urban areas. So we use like a LiDAR technology on your cell phone and the camera system to create a digital twin, like a CAD environment of different settings. And that's very important for the modeling purposes. And it's a really tedious and hard task to do, to understand what materials are there, what set of objects are there, and create like a detailed building information model. And we are based in Los Angeles, right? And I'm a former NASA JPL scientist too. So we saw that such technology can also be used for urban areas and urban mapping and urban modeling. And we also build the remote sensing technology to bring more information about the digital twin, which is going to be used in the fire simulation and other methodologies and other platforms.
Great. So what I understand is that Opal allows for more of a street view, which has been a real challenge for other AI platforms, I guess, that you're able to create this digital twin with a street view, and that will allow for a level of planning that hasn't existed before. Who typically, with that in mind, do you expect to be using Opal AI, and what are they going to be using it for?
That's correct, Neal. I think the field of robotics disrupted a lot of industries. And what we are doing is we use robotic systems and also technologies that are used for self-driving cars to create a more detailed map of the urban areas, in addition to the aerial data. So the people who are going to be using are the fire chiefs and the emergency managers, and also the wildfire risk manager at the utility company. So fire agencies and utility company, in addition to like maybe HOAs, real estate developers, homeowners. So these also can benefit from it.
Understood. So within those organizations, is this something that you see being used as part of a planning process or being used day to day as part of operations, or both?
So we're doing a lot of pre-fire, so in the planning phase, and to understand where the risks are. But for situations like the utility companies, it's going to be also day to day because they need to make decisions about the power safety, power shutoffs or PSPS almost on a daily basis, whether they need to do it, especially in the windy situation or in the situation that you have, the climate risks for the wildfire. So yeah, it's going to be in terms of both, but you can be prepared about, how to do the planning, how to reduce the risk in the urban areas, vegetation management, and also the city planning, and also evacuation planning. It all of these can be used as well as the day-to-day operation.
Let's expand on that scenario. So I'm a utility. I've got screens for everything. I've got cameras, detectors, vegetation, climate, weather, you name it. How is Opal going to bring all that together? Will it be eliminating feeds and bringing them into kind of your orchestration layer, or will it exist separately and provide some additional awareness?
So we gather the data from multiple sources, as you mentioned, the ground station, weather data, the satellite data, aerial data, street view data, and historical fire too. And it goes to our foundation model, which consists of the model that has been trained on a number of different historical data and creates insights about the risk, or we call it fire potential index. This data by itself requires, make some adjustments, right? So the human expert is our end user, which can be the fire analyst. They look at the data, maybe they have questions. They can ask questions from the AI, and it's going to be like the loop between the human and the AI that can make decisions about some certain tasks. And there's a lot of benefit in doing such an approach, because the AI has a long memory feature. It has like a much bigger token size than the human does, but and the type of intelligence it has, it's very fast. But in comparison, the human is more experienced. Like they know this problem very well for many years, and we are surprised how much human intelligence can benefit this, like in general, the AI system. So the human AI teaming is going to make the process more efficient and more accurate.
So back to the utility example. So I'm using Opal. What kinds of queries would I typically put in there? What kind of information would I expect to get?
So if you think about the fire agencies, you want to see that where are the risks in your city, that which homes are super burners. And if it comes, you suddenly, the fire would be uncontrolled. And how you can allocate your resources in a way that to reduce the risk. And you can run fire simulation, different fire simulation, specifically in the WUI area as well, to see that if you do the investment in these areas, you can get the maximum reward. And for utility companies, it's going to be different, because the same thing, but more on the utility assets, that you have in like maybe thousands of different assets, and in different locations. Some of them maybe have very limited information about, the status or even the model of these assets. And what it does, it says that statistically, if you are paying more attention to these ones, right? Because if it burns, if something happens, the fire would grow to the WUI area, or would be uncontrolled in some situation. So it's better to first focus over on those regions, do the vegetation cut, do some repairs compared to the other regions. And it's
So
going to prioritize the task. So it's optimization, and also the AI optimization framework, decision support framework. Yeah.
So I could query it and say, maybe during a Santa Ana wind event that's happening, it could take the weather into account with where the physical infrastructure is and the WUI, and come back with recommendations around where resources might be deployed or where the greatest risk might be. So it can help to your point, better allocate resources, where to put people who are going to be responsible for either detecting or mitigating fires, make sure they're in the right place based on all this data that's out there.
Correct.
Okay.
And we also can predict 48 hours ahead. And we showed that in Palisades, we identify some regions that were very prone to fire, and like the fire risk was very high. So in that situation, you can allocate resources in those regions, at least the regions that are in the WUI, like close to the WUI area.
So this is a space where there are a number of different companies making claims where they can ingest all kinds of information, camera feeds, sensors, satellite, and come up with this similar kind of decision support. What's different about Opal from the other AI platforms that do something similar?
Number one, we all want to solve this problem, and we would be happy to collaborate with everyone who is trying to solve this problem, because this problem is not solved. This year, 2025, in my own city, right, we observed that the entire town was burned. Like El Tadina was burned, Palisades was burned, and we see that none of the existing tools can support such a thing. So it doesn't work. So there is no solution at this time that can solve such problem. One of the differentiations that we do have compared to the others is how much support we get from NASA and our AI first team. The NASA is providing us funding. So we just received $1 million to build this solution end to end for fire agencies and utility companies. And they're supporting us in the future rounds too. Not only in the financial terms, but also every source, every, technology that exists at NASA, JPL, different sources. We have access to it. We're going to collaborate with them and commercialize it, which is a huge benefit for companies like us, and it's going to be a benefit for NASA as well, because in that situation we show the value of the tremendous, like the wonderful technologies that has been used into the society. Prior to Opal, I also was leading one of the wildfire initiatives at NASA JPL, working on how AI can help the wildfire too. So I was a scientific PI for that project, and we were surprised how powerful AI was, and that was honestly that was a few years ago. And now with the current AI technology, it's mind blowing that how much we can do, and it's very exciting to be in this world and trying to solve the problem.
So is Opal something that came out of being at NASA and seeing where the gaps were and saying there's an opportunity to be able to take this big volume of data and ingest it into a system that will provide a lot of good out there in the world? What was the genesis of, because you came from NASA and now you're working with NASA data sets? Help us understand the connection there.
Yeah, we are a spin-off from NASA JPL as well as UCLA. That's why we have very close collaboration with these two world-famous entities. And so there is like a very large group at NASA JPL working on the wildfire. And also many of you know about, different NASA initiative for the wildfire as well. We are trying to leverage these technologies to make it more robust. One of the things, like there are lots of new satellites launching by NASA, new sensors are being tested. So we are collaborating with them to bring these new technologies into the fire community.
So you're kind of like the commercialization arm of NASA for wildfire technology.
Kind of, we can say that at this time, yeah.
Okay.
Also, we get a lot of support from other big tech too. So we got into NVIDIA Inception program. The Google Cloud is providing lots of support, and Amazon. So we're blending like the hard tech technologies that are being at NASA, as well as the state of the art AI technologies that are being there, and with our own knowledge of how AI is going to benefit, like domain knowledge of how AI is benefiting the society. So we're making the best of two worlds happening.
There's a tendency sometimes, I think, that AI can solve all the problems that are out there. Where do you see the boundaries, or where do you say this is where we are choosing not to go with this? Is there kind of a line that you're not willing to cross in terms of this type of solution?
So AI right now is doing a lot of decision support, meaning that the cognitive load of the human that they need to do some data processing, data analysis is going to be reduced. We're going to see hopefully soon that the AI is going to come out and have the body like robotics and help the people during the firefighting situation and help with the fire. However, there are a lot of work in the workflow exists, like how you gather the information, how you are gonna communicate with the with different teams, and still the AI is not able to do these sort of communication, those sort of with different agencies, with different people, with the homeowner, society, how you're gonna um, bring the information to the public, and these are not yet there. But in terms of information extraction and how we're processing data, I think it's really good, and it can, in some situations, outperform human performance.
So with that in mind, how do you validate accuracy and performance outside of models and simulations?
In the wildfire, that's absolutely one of the biggest challenges. One of the naive ways of doing it is a historical fire. So you have data from the past fires, and then you're going to see the fire primitives. You see how they grow and where they grew. The other way is using the fire simulators. But the problem with the fire simulator is they're usually 50% accurate, right? Even the best simulator is 50% accurate. And that's for sure like a challenge, but I think that's what we can do, like a historical fire as well as some of the fire simulators.
Sure. So we've talked quite a bit about how this would work within a wildfire environment. Can you walk us through an example, a use case where Opal influenced an actual decision positively?
At this time, we are doing some tests, so we don't have the actual something that we can share to the public, but in a few weeks, yes, we're going to be able to do that.
Got it. So, what friction or hesitation do you often encounter when you start talking to people about Opal and how it can support a wildfire or WUI or fire intelligence platform like this? What kind of pushback do you typically get about this?
So one thing I found it really hard was there is an absolute need for such technologies. And as you mentioned, there are lots of noises. Many people are working in these areas, but the rate of adaptation is very slow, meaning that it's really hard to find the kind of decision makers to close these, let's say, pilot projects we want to do, right? And validate validate the technologies and having a fast turnaround time. So the friction is more on, the testing, doing the pilot projects and scaling the technologies, which is a common problem in almost all government agencies. And the problem is now you're trying to sell to the government agencies and state governments, and there are lots of paperwork. And for small companies like us, sometimes it's going to be really like overwhelming to do all of these paperworks.
So, when you're dealing with a government or a state, county, municipality, whatever it may be, they potentially already have wildfire cameras, sensors, whatever it may be. Are you easily able to ingest all of that data, or is there specific type of data that you're able to bring in and not everything?
So most of the camera data at this time are public, like Alert California, at least in the California state, and we are training on a number of different sensors. And the way that we train our AI system, it can get different data sources. So we are not limited to certain hardware. However, there is like a fine tuning for each hardware or for each setup. So that's why we need to do the pilot projects to make sure that the fine tuning has been completed. And after that, we can scale.
So, you mentioned government. Who are your primary target customers? Who do you think you can best serve with Opal?
So usually the fire. So if you consider like who is gonna be our customer or who buys it is like executive leaders in the fire chiefs, fire agency, director of emergency managers, and also the wildfire mitigation managers at utility companies. So these are like the two main customer, that we are. And but the users are like a fire analyst, operational planners, like emergency managers who would interact with the FireVision and with the dashboard to see the risk, run the simulations, and understand the risks.
Sure. We talked about how there aren't any use cases yet, but you're getting close to being able to talk about those. Where are you in terms of deploying this? Are you ready to deploy this in a environment today? I know you're looking for proof of concept opportunities, but if a customer today said, let's go with it, are you ready to implement?
Yes, we are actually working with a handful of utility companies and fire agencies, and we started the pilot projects with them. And we're fine tuning our results. And in I think a few weeks, by January 30th, we would have a lot of great updates on tackling the first part of the problem, how it would work. So if I want to just touch base what the Fire Vision does, right, and what elements it does have. So it consists of 4 different elements. Number 1 is the real-time fuel maps, especially in the wildland area. We developed a technology with UCLA. It's peer review published work. It's called Fuel Vision. that would provide high resolution. It can even be lower than 30 meters, updated map every few days rather than the previous methodologies like a land fire that you have to wait like couple of months or even years to get the update. We are capable of updating the field map in Scottenbergen, indices like a few days as long as we have the data. The other one is this dynamic risk score that we developed, Opal Fire Potential Index, that we can forecast the risk and dynamic risk, few days prior to prior to the event. Another very key exciting work is the Wildfire simulator. So most of the existing simulators are designed for the wildlands, and some people use these wildland simulators in the WE area, but it doesn't work. So we are combining, the existing wildfire simulator that are out there. Like there are a number of them. Like there is one Quickfire, there is one Fireside, and also the Warfire. So we can use any of these wildland fire simulator and couple that with our own WE simulator. And this is one of the biggest differentiations that exist because, and we have peer-reviewed journal paper about all of these works thanks to our collaborators. So it's validated by the community, the scientific community. And last is our AI decision support tool that what it can do is like with a natural language interface, you can query data, visualize risks, and do interactions. And these interactions can be helpful for a number of different decisions. One of them is the acceleration of the decision making for resource, as you mentioned, resource pre-positioning, like staging where the assets needs to be in like 48 hours, a couple of days ahead in advance, or power safety shut, like PSPS, power safety, power shutoffs for utilities, prioritization of the fuel reduction zones and planning, even evacuation zones and routing on the dynamic fire spread modeling.
Wow. So if I understand you correctly, you'll be able to do most of the tools that are out there today are more focused on forested or open areas. You're going to be able to do more of a WUI analysis and predictive analytics around where the potential vulnerabilities are within a WUI area, within the built
Correct.
environment. Okay, gotcha.
Yes.
That's fantastic. So we've touched on your background with NASA a couple of times, and I would be doing a disservice to the listeners of this if I didn't ask you to just give a few highlights because you did some very cool things when you're at NASA. So just walk us through a couple of those highlights because I think people will be very interested in hearing kind of how you took all that and brought it to Opal.
Yeah, indeed, working at NASA is like a dream for every scientist, right? Or every technologist. And over there, you learn how to dream big, how not to be afraid of tackling any problem. That problem can be colonizing another planet like Mars or building spacecraft to see whether life exists in Europa, which is the Jupiter moon, or like Enceladus, right? And bringing those experiences back to Earth and seeing that how we use these state of the art technologies for space exploration to benefit the society is very rewarding. And we see a lot of common, technology and common science between, what you do in the outside the planet Earth and inside the planet Earth. So during my time at NASA, I led like different groups, especially focusing on deep learning technologies. At the time where AI was not very hot, we founded the deep learning group at NASA JPL. We had challenges because the same challenges that the fire agencies right now bring up that, okay, how do you validate these? This is like a black box. We cannot trust this deep learning methodologies. It's like a data driven. There is no reasoning about it. And what we did, we tried to find solutions that it can address their needs and find applications that this state of the art technology can be used and disrupt. And one of the things that we did was for the Mars rover automation, right? So there are a lot of work that the ground data system, like the data is captured for the Mars rover Perseverance and Curiosity is being transferred. And then you see some data are missing and a lot of like a sensor data is getting back to the person called GDSA, ground data analyst system, or someone who reviews the data on a daily basis. And we automate the whole task and reduce the cognitive load of this person 90%. So so from that time, he was 90% free, and we were short in staff. So that also got featured in technology highlights of NASA JPL thing in 2021 as one of the technologies that AI can benefit the whole operations. And at NASA, we were able to work a lot of different projects, seeing different technologies, especially robotics was very relevant. And intersection of AI and robotics is the future, as we see in many fields. And the fact that when you work at NASA, you can dream big and not being afraid of anything, and everything is a matter of engineering, and nothing is impossible.
Well, that's a great way to end this. Listen, thank you so much for joining the podcast today, Ryan. I am so excited about what Opal AI is doing. It sounds like it's going to be a real game changer in wildfire detection and being able to manage the risks associated with wildfires, particularly with the street view elements that you have that really nobody has currently. And it seems like hopefully we'll see a lot less risk out there for people, for buildings, for everything, thanks to Opal's product. So thanks for joining us, and thanks for being here for another episode of Neal on Fire. Be sure to subscribe, and we will talk to you again in the near future with another exciting episode about wildfire detection, suppression, and mitigation. Thank you,
Thank you,
Ryan.
everyone. Thank you, Neil, and thanks for the listeners. Have a great day. Bye.